The topic we are presenting is based on a research paper titled Blockchain Improve Explainable AI for Just Healthcare System by Amit Taramosin. Here's the roadmap about presentation. We cover 6 sessions: introduction, method, system, architecture, workflow. Now here's the framework, is application and conclusions. Okay, so to begin, let's talk about the fundamental that the paper rest is what we call the trust gap in the healthcare AI. First, we talk about the data trust problem. Imagine that a patient data is sent from hospital A to hospital B. The question here is how can the doctor at hospital B be 100% sure that the data is complete and hasn't been altered anyway? We can only verify potential. There has a one way to read and we need the effective comparison between two hospitals. Second, we talk about the black box problem. We suppose that the hospital B uses an advanced AI to analyze the data and it reaches a high risk of disease. So the question for any clinician would be why? What factor led to this conclusion? If AI cannot explain its reasoning, so clinician will not fully trust a recommendation they will understand. Okay, so how do we resolve this broad challenge? The authors propose a elegant solution to the big data framework. The core idea is to combine two powerful technologies. First, blockchain technology, which ensures the integrity of the data. It creates a secure and unchangeable record of all information. And the second is explainable AI or AI technology, which provides transparency for the AI prediction, answer the why question. By integrating Z2, the big data will create a single and unified framework designed to establish end-to-end trust in healthcare AI, just ignores data and the decision. Okay, let's move to our second section and take a look at the system architecture. How is this framework architecture built? On the left, you can see the overall structure. It's important to clarify that it is an architecture diagram, so we components and data flow, not a workflow. And as you can see, the big data framework is built upon 5 interdependent layers working together to create a robot and chatbot system. The central idea behind the design is what we call the dual layer trust mechanism. Okay, let's break down this layer, starting with 3 horizontal ones. But we have the data layer. Here, Bayesian records we integrate using an advanced method to insert data complete privacy. And the second is the blockchain layer. This acts as a digital notary. It will create a record every single data transaction and control who has what set. And as a third, we have the AI layer. This is the brain of the system. It contains a predictive model that can analyze the data and to generate clinical prediction. Okay, building upon the foundational, we have 2 next layers. The following is the AI layer. The AI layer is the brains, and the AI layer is the translator. Its job is to generate human explainable Here in the sample is explanation or the AI prediction answering the why question, and the fifth layer, deployment layer, is user hybrid edge cloud architecture with me. Essentially, computation will be performed locally at the hospital, the edge, while the large-scale model training will happen on the federated cloud. And the design will perfectly blend balance, privacy, security, and computational power. Okay, so what is the design? Why, when the five layers work together? The design is a very powerful and elegant concept. The dual layer trust mechanism. But we achieve the data level trust guaranteed by blockchain. It ensures that the information going to the system is reliable. In a simple term, we can trust the input. And second, we achieve the decision level trust. Guaranteed by AI, it ensures that the logic behind the AI decision is transparent. And if it were, we can trust the reasoning. So that's concludes my part of presentation. So next my part will walk you through the detailed workflow.
Now I will show the workflow of infrastructure. There are 5 main steps. Step 1 is data creation. That's with a unique cryptographic task. The patient information such as medical imaging and health results will be listed on blockchain. Next to step 2. In federated access control, when an institution or physician wants to access the patient information, a smart contract enforce the user consent and legal standards. This can protect sensitive information by limiting sharing to verified entities. Next to step 3 in model duplication. That is using a model, AI model, to provide prediction and treatment suggestion. The answers and then are stored on blockchain. Next to step 4 is validation. When we have prediction and implementation on blockchain, institution now can independently verify the answers of the model to ensure that the model use correct input data and the explanation is accurately related to the answers. And the final step is step 5. That's clinical interface. That's when the answers are verified. Now it can be shown to the clinician. If explanation are secured with a blockchain certificate, ensure that it has not been edited after the fact, and it can grow the trust from the data to the reasoning behind the AI decision. And after that, the clinician can give feedback to improve the system. Next to the novelty.
Hello everyone, my name is Hoa and I will be dancing the novelty of DHL. Let's look at some key features of it. First, on-chain explanation. DHL record both AI prediction and their explanation directly on the blockchain. This ensures that all information is accurate, transparent, and cannot be tampered with. Next, The two-layer trust mechanism. PEHF builds trust on two levels. At the data level, PEHF blockchain quality data integrity and control setting. At the decision level, explainable AI makes model output understandable and verifiable. Then, digital security interoperability formalism. This means PEHF integrates security and interoperability into one unified system. So the model is not only safe but also explainable by design. It also supports regulatory alignment because every explanation and output is traceable on blockchain. PEHF naturally complies with standards like HIPAA and GDPR. Finally, immutable explanation provenance. All explanation is mentally stored on chain, which prevent any manipulation and standard overall trust and auditability. Together, the future must be both secure and transparent, a trustworthy system for your healthcare use.
So that was the overview of what's new in different work, and now my name is Ha, and I'll be talking about how it actually applies in real life. First, begin up with first begin with the hospital sharing medical data much safer and more transparent because it combines blockchain and explainable AI. Hospital can share patient records securely through blockchain, and these help doctors from different hospitals can work together. For example, when diagnosing rare disease or find the right treatment faster. Next, BNF help with clinical disease support. Normally, AI might say something like the patient is at high risk, but it doesn't explain why. And BNF changes us. It shows the reasons behind each prediction. That means doctors can understand and trust what the AI is saying, which is super important when making critical decisions like in surgery or intensive care. Then there's global research collaboration. Researchers around the world can use DNF to share verified medical data safely without risking privacy or data leaks. This allows them to work together discover new treatment faster and improve healthcare for everyone. Finally, through something called deferred learning, hospital can train AI model together without sharing any raw patient data. So the AI keeps getting smarter, but patient information stays completely private. Now let's move on to conclusion. BNF solved two main problems in healthcare: data sharing and explainable AI decision. It will track patient data safely, and help a hospital collaborate more effectively. And overall, BNF lays the foundation for trustworthy and transparent AI in healthcare. That's our presentation. Thanks for listening.